Welcome to our lesson on basic chemistry. So you might be wondering why we're learning chemistry and biology, but the two are actually related, especially in this unit, which is biochemistry. So life can be broken down smaller and smaller and smaller until it's broken down into components that are no longer considered living things, like molecules, and this is where some chemistry is going to come into play. So the smallest you can break any type of matter down is the atom. And the atoms can come together to make molecules. Molecules will form macromolecules, which are really big molecules. And in this chapter, we're going to be looking at this stuff, this chemistry type stuff aspect of biology, because these are the components that make up the larger biological structures. So atoms are the smallest units of matter. They cannot be broken down. They have three main parts: the electrons, the protons, and the neutrons. This is what an atom looks like. It's a model of an atom, what we think it looks like. And in the center is what is known as the nucleus. And the nucleus is made up of protons, which are positively charged particles, as well as neutrons, which are neutral particles. They have no charge at all. Around the nucleus are the electrons in an electron cloud. And the electrons are the negatively charged particles. Since the negatively charged particles and the positively charged particles, so electrons and protons are balanced, they're in the same number, the overall charge of an atom is always zero. Elements are pure substances. They are made up of only one kind of atom, and anything that's in an element is designated by an atomic number, which is the number that you find on the periodic table, and this tells you how many protons are in that element. The number of protons in the element determine which element we're talking about. For example, carbon has 6 protons. So if we look here, we look for number 6, we find carbon. That's carbon's atomic number. If I know something has 20 protons, then I know I'm talking about calcium. This is how elements are organized on the periodic table. It's by protons. Now, electron cloud has many levels, but the innermost holds 2 electrons, and the outer level usually holds 8. The outer level is also known as the valence shell, or the electrons in it are called the valence electrons. And these outer electrons are the ones that participate in chemical reactions. Basically, what happens with atoms is they like to have their outer shell filled with 8 electrons. And if they don't have 8 electrons, they're going to be looking for partnerships, and they're going to look to hook up with other atoms so that they can fill their outer shell. So let's look at what that really means. Here is sodium. So we're going to look at the valence shell and count how many electrons it has. So if we go here around this outside, there's only 1 electron in sodium's outer shell. So sodium is very reactive because it's missing 7 electrons from its outer shell. So sodium actually is going to be looking to form a partnership with another atom so that it doesn't have this issue of a mostly empty shell. It's reactive. The second example, this is fluorine. So fluorine has 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell. So fluorine just needs 1 more to have a perfectly filled outer shell. So fluorine is going to be looking to form a partnership so that it can get just 1 more electron and fill its outer shell. And then our third example is neon. So let's count neon's electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. That means neon's valence shell is full. So neon is super happy just the way it is. We say that neon is stable. It will not form any type of chemical bonds with other atoms because it has a stable outer shell. It is not reactive. So what happens when that outer shell isn't filled? How do atoms combine with each other? And there's different types of bonds. Covalent bonding is a type of bond in which atoms are going to share some valence electrons. A molecule is a group of atoms held together by covalent bonds. So an example of a covalent bond occurs in water, and another example is between these fluorine atoms. So before, we looked at fluorine, and we said that fluorine has 7 electrons in its outer shell. So it's really looking for 1 more electron. So what can happen is that 2 fluorine atoms get together because they're both reactive, and they end up sharing a pair of electrons. These are the 2 that they are sharing. In this way, both fluorines end up having 8 electrons in their outer shell because they're sharing that extra electron. So here, now we have 1, 2, 3, 4, 5, 6, 7, 8. And the other fluorine also has 8 because it's using this pair to in itself as well. So this is a covalent type of bond. The other type of bond is known as an ionic bond. An ionic bond forms when one atom gains or loses electrons to form a stable valence shell. An ion is an atom or a group of atoms that has an electric charge, so it's no longer a charge of 0, because it either gained or it lost electrons. If it gains electrons, it's going to be negatively charged. If it lost some electrons, it's going to be positively charged. And because in an ionic bond, one is positive, one is negative, the two are going to attract each other and they're going to be held together by an ionic bond. So we looked at sodium before and we know it has this inconvenient electron in its outer shell. So sodium doesn't really want to find another 7 electrons. It kind of just wants to get rid of this 1 electron because the next level is all good, it's all full. So what can happen with sodium is it will hook up with chlorine, and chlorine has 1, 2, 3, 4, 5, 6, 7 in its outer shell, and sodium has 1. So sodium will actually give up that 1 electron and give it to chlorine, and then chlorine can have a full outer shell, and sodium can as well because it no longer has this outer shell with the 1 electron on it. And in this process, sodium loses an electron, it becomes positive, and chlorine gets an electron, so it becomes negative, and the two are attracted to each other. This is how sodium chloride, which is the salt that you use, is formed. And here it is, table salt, sodium chloride. That's how it works through ionic bonding. Now, polar bonds are a type of covalent bond where electrons are shared. And it's where they're sharing unevenly. So it's like when you split like a cheesecake with your friend and your friend gets more of it than you do. You're not sharing equally. That's a polar bond. They're sharing electrons, but they're not sharing equally. So for example, in water, water is a polar covalent bond. Oxygen hogs the electrons more than hydrogen does. So hydrogen ends up being, the hydrogen end of water ends up being positively charged, and the other side is slightly negatively charged. And what happens because of this is that water molecules actually are attracted to each other, and they form hydrogen bonds between them in the positive and negative parts of each. And these lead to some important properties of water, like cohesion, for example. So here's a nice summary of the different types of bonds. Electrons are shared during covalent bonding. Here they're shared equally. Here they're shared unequally. This is polar. And then this is the ionic bond where they're not sharing at all, but this one has lost electrons and this one has gained electrons, and now they're attracted to each other. Solubility. Water can dissolve polar molecules like sugar and ionic compounds like salt. And you've probably seen this, right? If you put salt into water because you're boiling it to make pasta, the salt dissolves. It doesn't just sit on the bottom. If you're making tea or coffee, you can dissolve your sugar inside of that water. This is solubility. Water can't dissolve nonpolar substances. That include things like oils or fat. Those will actually just float to the surface and they won't dissolve at all. Water molecules are attracted to each other and they have hydrogen bonds between them. I mentioned this earlier, and that leads to some interesting properties of water like cohesion, and also we'll talk about adhesion later. Hydrogen bonds. So when bonded to oxygen, nitrogen, or fluorine, hydrogen has a partial positive charge. It attracts nearby molecules. An example of a hydrogen bond occurs in DNA. And we'll learn about DNA later this year, but they're held together. There's one strand here, and they're held together in the middle by hydrogen bonds. Hydrogen bonds also occur between water molecules, as we mentioned earlier. So I want to show you a little fun video where dogs teach chemistry, because I think they do a better job than I do. And it was uploaded by some YouTube user called Snuggly Puppy, who is a chemist but also trains dogs. So I really hope that you enjoy this video. And here it is.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.